interwebs, welcome to Let's Fix Computers. I've got a Thrustmaster TS-XW Racer racing wheel here. This thing is immense. I've just been unboxing this and going, wow, this is a hecking cool sim wheel. So this has obviously come out of a fairly decent sim setup. It's got really, it looks like it's got a lot of modified parts on it, but the actual, like the gear shifters on this and stuff are immense, proper big clunkers and everything. I love this thing. However, I'm not in here to show that off. I'm in here to fix the very broken USB port on the back of it. As you can see, that's supposed to be a Type B port, and it's gone. So, yeah, the owner of this thing sent it in and said, oh, I want to get that replaced. And sometimes when people send in peripherals and stuff like that, I'm just like, are you sure it's worth it? But like, as soon as I opened the box, I was like, oh, this thing would not have been cheap. I know that you can get some really serious racing setups, and some of them can cost really serious money, but this is just the tip of the iceberg. There's a full set of pedals and everything in the box as well, but that's not what this is about today. So, having showed you what it is, let's get this arranged on the bench and we'll take it apart and see how to replace that USB port. Also, honourable shout out to the fact that the power brick for this thing, I call it a brick, it's literally in the shape of a turbo. And it's literally called the Turbo Power 220 volt, which that's just like, this is functionally useless, but that's hecking cool, isn't it? It's literally a massive toroidal transformer. It outputs 24 volt alternating current. So yeah, it's rather than giving a switching power supply, it's just got a massive donut in there. A donut and a snail. So if we turn this thing upside down, and the bottom plate here is all metal. It's very heavy, but that's just because it's got, you know, all the force feedback gear in there. Loads of hex bolts on the bottom of this. There's a couple around the sides as well. I think what I'm going to do is start by taking out all these hex bolts on the bottom and just see what that gives me access to. I'm kind of hoping that just the entire top cowl will come off. But I don't know what's attached to what. I don't know whether all of the internals are going to be attached to the bottom or some kind of chassis inside. Those look like big structural screws. Either way, I'm going to start off just by taking out every screw I can see, and we'll just start seeing what comes off. So, right, that's all of the hex screws out. Let's see if I've made any progress here. I don't think I will have yet, to be honest. Some stuff is moving, actually. I think a lot of this stuff on the side might just be for cover plastics and fascias, but then those might be covering up additional screws. You never know. Let's put this up right. I'm worried that by taking out some of these screws, like these ones, I'm not actually going to progress toward getting the covers off, but just make everything inside loose and rattle around, which doesn't actually do me any favours. Nope, I don't think this is working. I'm going to take out more screws. So we're kind of falling into the take out every screw in sight thing here. I think a lot of these screws that I'm removing now probably don't need to come out, but I'll take them all out and then I'll figure out what didn't need to come out, put that back in and tell you what the results were. Right, so this side panel, this hasn't got me any closer to the top coming off, but it does give me a view on the inside. I think these front middle ones need to come out. I'm going to take those out. Aha. Right, those four Phillips screws removed this front ring from the wheel mount. And that has revealed more screws at the front here. I reckon if we take these out, that's probably what's holding the top case on at this point. There we go. So there's the big ass motor that does the force feedback. That's a belt drive onto a gearbox system into the actual wheel itself. I wonder if that's a stepper motor or whether it's just a apply force in either direction. I don't know. I don't know much about these systems. That's what we're here for, that controller board. Wow, look at all those MOSFETs. That's a lot of drive circuitry. All right, so it looks like we can just disconnect everything from that board and take the board out, and that's what we're going to be working on. I see additional damage in there. Let's hope that's not too bad. Okay, I'm going to flip this thing over. And firstly, I'm going to put all the screws in that didn't need to come out. I'm going to put them back in. I'll take a picture of all these plugs just so I can see where everything was plugged in. Ooh, that's rude. We've got a soldered boy there. Okay, well that'll be fairly easy to spot. I was about to say that those solder pads were a bit disappointing to see, as that immediately makes this a much more daunting job for a DIYer, but we're going to be resoldering a USB jack anyway, so never mind. Feels like something's plugged in on the back. Yeah. Oh, that one's got some hot glue on it. There we go. Let's take a look at this guy then. So lots and lots of motor driving up the top there for all of the feedback stuff. The back has got some extra stuff on. We've got some big input capacitance here. There's a big bridge rectifier there. So although this thing has got an AC input to it, it looks like the first thing it does is just rectify that to DC anyway. Then after that, we've got the controllers, and essentially this is all just motor drivers, and there'll be a little bit of data logic for the actual button inputs and outputs. So what we're interested in is the USB port here. So we need to find ourselves a through-hole USB type B port. This shouldn't be too difficult to find. That's probably a very generic part. As you can see from various plugs and unplugs, possibly from being pushed into the back of being pressed up against a wall maybe, the plug has just been forced inside of the unit and it's just pushed everything out. Somewhere in there may well be the actual guts of the thing, or that may have been pulled out on the plug. So what's got me most concerned though is down here. We've got some damaged parts there, and I don't know what that might have been. If we study the silk screen, we can start figuring some of this out. So we've got C22, C21, so that's capacitor 21 and 22. Then we've got ESD2, which is probably this device here. Then here we've got C10 and C11. C10 is absent anyway. You can see those pads are rounded, which means it was never fitted in the first place. So that cap is deliberately absent. That's called no stuff. However, these pads here have been disturbed. You can see on the close-up there where stuff is clearly broken off from there. So the question is, what was ESD2? What is that? I'm not actually sure. I'm going to ask around and see if I can find out vaguely what that might have been. And then also I'm going to track down a USB port. So I'll find out what this stuff is and I'll get back to you and tell you about my findings. So the two components we need are a USB Type B female port. That's easy to find. You can find it on eBay anywhere you look. And this missing SMD part, what I did was, it's labeled ESD2. Now, because that's marked ESD2, I thought, well, the chances are there's another one somewhere on the board then in that case. And we can actually see just straight away we've got ESD3 right there. And that is a TVS diode. And if we look around this board, there's more of those. If I turn it over here, this connector here, that's the pedals connector. Then we've got the gear stick connector here. So where these connectors are from going to other components that are external devices, these are all protected by lots of ESD TVS diodes. And what these are, they're transient voltage suppression diodes. And what that is it's a diode that acts as a brick wall to any normal voltage. But any voltage that exceeds an expected value, it will allow to pass to ground. So, for example, on our USB port, we're expecting 5 volts here. However, if we see anything above 5 volts, let's say 6 volts or even a 2000 volt static spike, because someone got a static shock off of the wheel, as soon as it sees that high voltage, it's just going to immediately bridge that down to ground. So that prevents it from then going through to the controller. Or vice versa, if we've got a static shock from the device, it stops it going back up to the computer as well. So we know that this is going to be another TVS diode, but it's got 4 pins on it, and that kind of flummoxed me a bit. So I did a search for 4-pin TVS, and it turns out that there are specific TVS diodes specifically for USB ports and the like, which isn't really surprising. So if we take a look at this, so here's an example one I found by NXP. And if we have a look at this guy here, it's an ultra-low capacitance double rail-to-rail ESD protection diode. And if we have a look in the applications, it is designed to protect USB 2.0 ports. So let's scroll down to the diagrams and it'll make a bit more sense. Here's the pinning information. As you can see, it's got 4 pads, with pad 1 being slightly bigger, and that corresponds to what we see on the board as well. Pad 1 is slightly larger. So pad 1 is our ground, then pin 4 is the 5 volt supply voltage, and then 2 and 3 are for the 2 I/O pins for the USB port. And if we look at this internal diagram here, you can see that each pin passes through internal diodes down to ground. So essentially, it separates the pins out and provides ESD protection for all of them in a single package. So this is what we need. So I did discover that RS Components will sell these. However, the minimum order quantity is 20. So by the time I've ordered 20 of them at 40 pence each, that's going to cost me £8. And then with the VAT and delivery on top of that, plus the minimum order quantity for our USB connectors, it clocked in at £21.80 for these parts, which is just, this is the problem when you do one-off repairs like this. Even if you buy from a completely legitimate supplier like this, it's very, very difficult to get any kind of reasonable pricing, which is why I often end up going to eBay. So jumping over to eBay, I searched for the same parts and I can get 5 USB ports for £2.81, and I can get the TVS diodes for £155 plus £180 postage from China. So this brings our total cost to £6.15, much more reasonable for a one-off repair. The downside is I'm probably going to be waiting 3 weeks for these guys to show up, and that kind of sucks. However, it's a quarter of the price that I was getting from RS Components. Now, I'm sure if I shopped around, I could probably find someone with slightly cheaper prices than this, but let's pretend that we managed to find these at half the cost. We're still looking at £10 versus £6 if I'm willing to wait a little bit. So we'll do this, because otherwise at £20, it's going to start getting really questionable as to how economic the repair actually is. So I'm going to go ahead and order those, and I'll see you guys when I've got the parts. Bye for now. Parts have been acquired. We've now got some of these little TVS diodes, and we've got some new USB ports. So now we just need to remove the remnants of the old stuff. So we'll just be able to soldering iron all of that off. So I'll just get the soldering iron, put a big blob of solder there and just wipe that off the board. And we'll have some nice flat pads for this guy, no problem whatsoever. The USB port, the remnants of that, let's see. I've really got to get myself some low melt solder. I'm going to order that as soon as I finish recording this because, in fact, I'm going to pause and order some now because, my God, I keep forgetting. There we go, it's done. So if I had some low melt solder, I could mix that into this solder to lower the whole melting point, and then a hot air gun would very, very quickly keep that molten and just whip that out nice and quick. However, I keep forgetting. So what I'm going to do, I'm going to mix in some regular solder just to get things flowing nicely, and then I'm going to use my desoldering gun just to get the worst of that off, and we can get the rest of this guy out. Might chop that out. I don't think I will. I think that's going to be more trouble than it's worth. We'll see. I don't know. I'm just going to wrestle this thing out. Desoldering, I'm not a pro at desoldering stuff, so I kind of just use all the tools I have to hand and it comes out eventually. Then, once we've got that off, I will use the desoldering gun to clear the holes because that will work a treat on these. Those are some massive blobs of solder. It's a little bit heavy duty for this iron, but we're getting in there. There we go. Right, is that going to happen? Maybe. Oh, job done. There we go. Desoldering gun, go burr. Oh, I was a bit too quick off the mark for that one. The desoldering gun isn't very popular in the comments section, but that's because I'm still sort of figuring out how best to use it. But I don't know, you can't argue with that. That heckin' worked. Those holes are massive, which definitely helped things. Cool. Let's clear up those holes as well. Just flow some fresh solder on those. Beautiful. Damn it, I just put solder in that hole again. Redo that in a moment. There we go. So we've got all nice clear holes and nice flat pads. So I'm going to put on our TVS diode first because once I put the new USB port in there, there's going to be a lot less space to move. So I'll open up this pack. We've got 5 of these little dudes, so I've got some spares, which I'll probably never need, but whatever. Always order more than you need, because A, it means if you screw one up, or you drop it, or something like that, you've got another one. And also, like, you never know what you're going to need. And every now and then, not very often, but once in a blue moon, I go to, I see a component that I need, and I think, oh, I've actually got one of those. I've seen this component fail before. It does happen. It's crazy, I know. So that's going to go that way around. And I'll just put some flux on there. The flux obviously makes soldering easier, but there's also an added bonus effect of flux is that you can use it as just a little bit of goop just to stick things in place. There we go. So now this guy isn't going to fall off if I jog the board or something like that. All right, soldering iron. I'm going to come in with a massive tip that's much too big for this, but will work just fine because we've got lots of space. And I'm just going to tack down one corner. And I'll now just straighten that out. Got to move things around so I can get in there with... There we go, that guy's nice and straight. And now we'll just tack down the other legs as well. Way too much solder, so we'll just clean the iron and then go in again. There we go. There's too much solder on that, but it's fine. Better too much than too little. Now we'll stick on our USB port. So nice and easy, 4 legs. We've just got to make sure that they all go through the holes. And these anchor points are a bit how you doing, as they say. So what we're going to do is I'm literally just going to flood fill these holes with solder. So yeah, here goes nothing. I'm going to try and hold the soldering iron against the leg itself. There we go, there's one. There's the other. Visual inspection. That's flat on the board, and yeah, that'll do it. That's not going to come off. And pins. There we go. I didn't clean my tip very well while I was doing that. Because I poured a crap ton of solder into here, I put a load of slag on the tip, so that's what that black stuff is that's come off. That's not ideal, but I've reflowed those joints. Those will be fine. That's just cosmetic. So I'll give this an alcohol wash now. Schmack. Schmack. And I'll use a toothbrush just to brush off the flux. There we go. Like I bought one. That'll do. Right, I'm going to go ahead and reassemble this now, which is basically just going to be the reverse that I took it all out in. So we'll go on to fast forward for this. I've got to get all the bits out and put them all up on the bench again. See you after the cut. Right, we're all reassembled now. I'm going to set this up somewhere so we can test it out and see it in action as well. I don't need to do a full setup just to see if it works. I can just plug in a USB cable and probably just turn the dial on the front to get an idea if it's working. However, I'm going to do a complete setup, so if nothing else, you guys can just see what this thing is like in action. I said at the start of the video that, oh, this thing's probably worth, I don't know, 300 or 400 quid. Spoilers, it's a lot more than that. So yeah, let's get this thing and see it in action. Right, I've got a rough setup for this thing now. We don't have the pedals because I told the customer not to send them to reduce weight, and I'm very much regretting this because now I have to play a driving game with no analog accelerator. So I've dialed in these two buttons to be my accelerate and brake. It's terrible. I've already tested this. Anyway, it'll give the impression. Watch me fail. Let's go. This is Dirt Rally, which I haven't played for about 5 years. So the force feedback works just fine, as it would do, and it's absolutely savage. I've never really spent a lot of time with any kind of simulator setup in the slightest, so I'm really unpracticed at this. So I'm kind of crashing around. But the wheel feels great to use. Oh, we're going off. It's okay. When I was fiddling with it on the bench, these shift paddles, seem brutally heavy, but once you're actually in the game and you're just smashing up through the gears, it makes a lot more sense. Oh shit. Oh, that's off. Luckily I span it. I'm mostly using the gears to control my speed here, which I shouldn't do. Oh god, tank slapper. Okay, it's fine. It's not fine. Don't you give me a recover vehicle. I'll tell you when I need recovering. Oh, I think I just killed a man. Yeah, I just killed a man. Sorry, that dude back there. You shouldn't have been standing there, if I'm honest. Oops. Well, I think that'll do. I think the wheel works, and it works well. Thanks for watching, everyone. I'll see you next time. Bye.